Impetus, an international MNC, US-based MNC in India, past 6-7 years. So right now, from past 3-4 months, I've been here. So the purpose of this seminar today is to give you some overview of where the current IT industry is moving on, what are the trends that are falling in today's IT, and are we really into that step where global IT is moving. So talking about this, so we have two seminars basically today, two topics for the seminar. One is Big Data and IOT, the current IT trends, and the next IT revolution, which I'm going to briefly talk about what is this and how it is going to be handled. So apart from that, we have next topic, which is laptop electronic engineering. That is how laptops are becoming more smarter and smarter, how the technologies is being evolved from past 4-5 years, 10 years to right now. So without further ado, I would just like to talk about some few basics about big data. So when you talk about big data, so evolution, we just, there is something hype that big data is something different thing in the current industry. In fact, this is not different one. So big data is nothing but large amount of collection of data which is gathered from your multiple sources. Previously, what was there was, we had lots of, we were not having multiple sources where data were getting generated. In traditional systems, if we talk about past 5 years or 6 years or 10 years back, the trends were, we have telephones, we have old desktops with some kind of floppy kind of disk and some other kind of cards. But nowadays these all has been evolved with some kind of dynamism. Like telephones have become smartphones. So now smartphones are not only phones, they generate data every few seconds. For example, you operate Facebook, you generate data. You like somebody's post, you generate data. So every click, everything is getting turned into your data. Next we have desktop. Previously desktops were like the space, memory capacity or data, what was being evolved previously was very small. We have small, for example, if we talk about floppy disk, in floppy disk we have 512 maximum or 256 MB of data, not more. But now the trend are being changed. Now the data has not only been grown up from megabytes to gigabytes or petabytes or exabytes, it has evolved so tremendously that the data is now itself in cloud. So when you talk about cloud is nothing but it's simply somebody else's computer. But the only difference is the computer has become accessible for sharing data. That's all is cloud. Now we have cars. If we talk about cars, vehicles, automobiles or vehicles, traffic management system or anyone, these systems are generating your huge amount of data. For example, now the cars are evolving in a way that they are automatically getting some kind of smart sensors. For example, for if something accidental objects comes in front of moving car, then the sensor automatically recognizes it and car gets stopped. So those kind of things are trending in today's industry. Now this is where we have the future opportunities as well. So are we really into this technology? Now there is some kind of problem here. So data is being gathered in huge amount, in finite amount. We are getting data in a huge amount, in finite amount. But these data are just scattered. We are not managing this data. For example, you like the Facebook post, but you don't know what is the use of that. you recharge your mobile system. For Nepal Telecom is having lots of data, but it is unused. So data is not getting used properly. So this data has lots of value. For example, Facebook is one of the industry technology giant which is properly using it. Your likes are for Facebook. Your likes are the business point. Once, for example, you have one kind of business which is sales type of business. Let's take an example. It's a sales type of business you are promoting. If you promote this Facebook page into hundreds of thousands of users, Facebook will get money out of it from other brands. So these kind of things are happening with the data. If we talk about only social media, around this much likes and 200,000 photos are getting generated per day. If you also talk about YouTube video, 300 hours of videos are uploaded so far. And there are lots of emails getting generated per day. So these kind of things are there existing in the market. Data is getting generated, but we do not have current technology does not support these kind of all those features. So we do not have mechanism to handle this data properly. So what to do in that case? So there is where we find some value. We find some value with advanced technology. There is a need. If we talk about traditional database management system, you must be aware of relational database management systems. What happens in relational database management system is you are having certain kind of data which is in fixed size. It does not grow beyond it does not grow beyond the limit of terabytes or gigabytes. If it goes beyond that, it can't handle it. So we need some kind of sophisticated mechanism where data has to be scaled up, data has to be managed and processed in efficient manner. So these kind of things can be handled with latest technologies such as we talk about big data. So this is big data. And again, when you talk about big data, in relational database management system, what we do have is some kind of structures. If we talk about relational database, there is a table, there is a column, particular column which have particular type of value. For example, if you say there is a column named name, it must have a kind of string. Or if you talk about price, it must be an integer. So, but if we talk about social media, so the nature of data, the type of data, we do not know what type of data it is. Data is completely unstructured. We do not know what type of data it is. We have a video type of data, we have a text type of data, we have audio type of data, we have photo is another type of data. So we do not know the variety of data. What type of data it is, we do not know. So how to handle these data efficiently? That's a great challenge in current industry. So to handle all those things, we have something that is big data. So if you talk about big data, multiple people there is a trend of doing online shopping. You do shopping from Amazon.com. Right now in Nepal as well, multiple online stores have been growing up. Educational sectors, government sectors are generating data, hospitals are generating data, insurance companies are generating data, lots of companies are generating data. So each of these companies are generating data. However, these data are not getting properly monitored, properly managed. Because data is so much. It's structured, it's unstructured, it's a semi-structured. Now when we talk about data, we talk about V's of data. When we talk about big data, we talk about V's of data. So B means to say, this first V, that is volume. So there is an infinite amount of data getting generated all around. So everyone is using mobile phone. If we talk about only the data getting generated from mobile phones from all of us, so it might be more than terabytes of data, right? we have audio data, we have video data. Next we have some kind of structured data like JSON, XML file, CSV file, Excel files, right? Email is again generating a data. Log files, system records. For example, banking system. If we talk about banking system, there is a when you withdraw an amount from ATM card, what happens? The logs are getting generated. But are those logs getting properly evaluated, properly analyzed? No, you don't know. Maybe there are some kind of fraud kind of transactions being happening. Some user might be trying to enter an invalid pin into ATM card and try to hack the code. So do we really are able to process these data and find out some kind of value out of it? No, right now not. Because traditional systems are not so much capable to handle and manage efficiently those type of data. So at that point we need big data, some kind of mechanism, some kind of technology where this semi-structured, structured or unstructured data can be processed and handled in an efficient way. So next we talk about variety. So again, varieties, we have semi-structured data, different type of data is there, file, photo, image files are there, audio files are there, videos are there. So these are different kind of varieties of data. So we need some kind of uniform mechanism where we would like to process and handle those things in a uniform way. About velocity. So velocity means to say that data is generating so fast. For example, if we only talk about Twitter or Facebook is generating more than 10,000 of gigabytes of data per second, per minute. So what if we would like to find out some valuable information out of it? If you run in Facebook, take simple example into Facebook. There is something called as most trending topics, right? I hope all of you open Facebook. So if you see their most trending topic, so that is something like maximally what text or what information has been texted into Facebook, posted into Facebook. For example, congratulations Dr. APJ Abdul Kalam. So if this word or letter has been repeated for more than 1,000 or billion times maximum, so that is what is most trending topic. Now this is a real time data, not exactly real time but near real time data. So how would Facebook know that this is the data what is getting mostly repeated? Because Facebook has lots of data. It has billions of rows into its database table. So out of this billions of rows, if we have to query and find out that this is the word which is getting repeated for maximum times, so how would this do in a real time? So this is what is velocity. When you talk about velocity, the rate of ingestion of data is very high. At the same time, the evaluation and computational capability of machine or your programming should be in parallel, should be at least near to that. So if we would able to do that, so that is what we are doing some good work. If we talk about traditional database management system and with a single programming, if it is not a parallel programming in a single node, if we are doing something valuable calculation out of it, at that moment what would happen is a single program running on a single machine could take more than 10 or 15 days to analyze this type of data, to find out what has been maximally been posted into Facebook. So to cater all those problems, so there is a velocity. So what that is do is, so when Facebook tries to find out that what is that word which is maximally getting repeated on post, so Facebook will deploy hundreds of thousands of nodes, computers, for working into parallel. right? In this way, it is able to find out. It is able to find out that what this is the topic that is getting generated right now. So efficiency is very important. Next, V is your value. So value means to say that is your data is really valuable? Yes, of course. So for example, the data what you are generating is not valuable for you, but that data might be valuable for other one. For example, if you talk about Facebook, you just post an article into Facebook. It's not valuable for you. Might be it's something simple for you. It's something 2 or 3 or 4 or 5 or 10 or 15 likes. That's nothing more. But for Facebook, it's all a business. So it will sell your data to somebody else, to the profile of somebody else business. So this is what is value. And next one is veracity. So veracity means to say that uncertainty and inconsistency. What is the inconsistency in the data? So do you able to predict that this type of data is getting generated, and do you able to find out what exactly is the outcome getting generated out of this data? So if you were able to generate those kind of data, so that is what the best optimization in big data. Talk about, for example, weather forecasting. One simple example is weather forecasting. If we talk about weather forecasting, so if we are able to exactly and precisely know that the temperature after 3 days would be this much degree low or this much degree, by analyzing historic records of last 10 days or 15 days, how much better it would be, right? There are storms or hurricanes coming into hurricanes. Lots of hurricanes come. Last time if we talk about Japan, there were a lot of earthquakes. Frequently earthquakes come over there. But if we were able to find out and sense that what are the things that are actually influencing those kind of factors, and analyze those kind of data in a precise manner, in a real-time manner, lots of value can be generated out of it. You could actually save human lives in a very efficient and better way. That is what is real-time value generating out of data. So these are the 5 B's that we talk about the big data. The first one is volume, next one is variety, third one is the velocity, next the value, and fifth one is the veracity. So these are commonly known as 5 B's in big data. So this is the big data. So we talked about big data. Now in parallel to big data, there is another one giant that is currently being running. So that is IOT. So IoT is something known as Internet of Things. That means to say, how do you make your devices more smarter and smarter with the usage of internet? If I say happy birthday something XYZ, maybe it should play a song into that person's home, that happy birthday to you. So these some kind of small kind of sensings, those kind of sensing. Another example is your AC. If your AC can become smarter to read your body temperature and adjust the temperature of AC automatically, adjust the room temperature of AC automatically, how would it be better? So these kind of things can be done with IoT. So what it will do, there will be some sensors which will continuously monitor your body temperature. It will send data to somewhere around the internet. Now your AC, what your AC will do, your AC will pick that data from out of internet and adjust that temperature. Adjust temperature of room. So these kind of smart thing can be done with IoT. We talked about smart cars. If some object is if suddenly some object has appeared in front of you, brakes will automatically be pushed off. You don't need to take care of brake. So these kind of sensing, if we talk, this kind of sensing can also be implemented via Internet of Things. So this is again, so IoT Internet of Things is nothing but all those data what is getting generated out of your device, out of your surrounding, and getting interconnected with your devices and making those devices smarter and smarter. So one example here is hospitals and doctors are there, patient monitoring systems can be implemented, blood pressures, the device that can monitor the blood pressure of patient, or insurance companies may implement devices for getting some smart insurance schemes. Similarly, retail stores might also use this IoT kind of product. For example, there might be a trend of purchasing mobile phones, smartphones. So what type of smartphone is getting generated, what type of smartphone is getting sold in bulk quantity. So those kind of data can be useful for retail stores. So these kind of smart intelligence systems can be implemented via IoT. Public transport companies, if we talk about public transport companies, you would have GPS based systems. GPS based system, what GPS based system would do is it will track where the vehicle has been going out. If we talk about, for example, there might be a salesperson who might have to visit tens of the stores, or who might have to visit some location where he might have to visit some location and collect some useful information out of it. But if there is no person, if there is no one monitoring him, he might skip that. So all those kind of things can be monitored via your IoTs, Internet of Things. If your GPS is made smart and if your GPS sends data to the internet, somebody else, an administrator can monitor him that where he is going on and what he is doing currently. The most important, and if we talk about very important aspect of IoT, the one you see in traffic management system. If we talk about real problem in traffic management in Kathmandu, so there are the traffic police who are running here and there and rushing over the problems, stopping somebody else and passing somebody other ones and all. So these kind of very stuffy kind of problems can be very efficiently handled with the use of IoT. What if there might be smart systems, smart device that is placed in traffic management that can be placed into road, public transport road, which can monitor automatically and manage your traffic automatically. If it can sense that where is the flow of, by which way the flow of vehicle is more, just allowing it to pass and blocking others, stopping others. Those kind of smart things can be done very efficiently with IoT. Now this is something related to processing of big data, that how big data comes into picture and what are real process that are implemented into big data. So first one thing is collection of data. The first thing is collection of data. The collection of data means we have lots and lots of data, scattered data. We do not know where this data is. You are generating data by your phones, you are generating data at hospitals, you are generating data at traffic. Everywhere there is data. So the collection of data is first thing into your big data chain. Next, you ingested this data. You collected this data and ingested this data into a single data store. So this data store is known as Hadoop. In big data, this data store is known as Hadoop. So Hadoop is a processing framework where we do have SDFS, Hadoop Distributed File System, where it can store any type of structured, unstructured, semi-structured, or any type of data. So this data is ingested into your big data store. So next, now data has been ingested. Now what's the next term? Next is your data is not filtered. Your data is not Your data is not in an appropriate form. So your data, for getting value out of it, your data must be in a single structure, single processed format. So there is where you do some kind of cleansing. For example, if you are collecting data from multiple, if you are collecting data, for example, talk about collection of photos. If you are collecting photos from, for example, if you are collecting photos from Facebook and Twitter, the Facebook may have some kind of date stamp, date time over that picture, and next one, Twitter might have some different kind of schemes for storing its date and time. So this date and time should have to be uniform format. So this can be done via your cleansing process. Somebody might be having your date of birth. Somebody might be having, if you are talking about relational database, some relational database, there might be a column named as date of birth, and another, some unstructured database or unstructured file might have a column named as date of birth. So these two are different things. So for processing them, you need some unified kind of format. So this is where you do the cleansing. You remove unused or unnecessary data, and you process it or clean up and make it usable for discovery, finding out some important analysis. Now next one thing is integration. Integration means to say that how do you link your data with another data? How this data is related with another one data. Linking is there. Entity extraction, for example, might there be some kind of valuable information that you want to only extract and process, excluding all those kind of things can be done by integration. And next, these two are a very important part of your data. The next one is analysis. So analysis means to say the data what have you been gathering, what have you gathered, is it really valuable to you? So this is the matter of question. So this is where lots and lots of research goes on. Analysis of data. So here is where lots of machine learning and AI algorithms are deployed to find out some kind of valuable information out of it. If we talk about the fraud detection systems, there might be a multiple fraud attacks being implemented. There might be multiple fraud attacks being done in ATM machine. At that time, so the logs are being recorded in the bank, but those logs are not getting processed. Those logs are still remaining same. So what if you can process those and find out that these are the logs, these are the outliers, which are some kind of fraud entries? What if you can find out that from this location, from Kathmandu Bagh Bazaar location, there are some kind of invalid entries, invalid fraud entries getting generated? This is really a valuable kind of information. So this can be done via your big data analysis. And next one is delivery. Delivery means to say that how well you can present your data into visual forms and present it to the world. So this is what you do have. It might be in the form of visualization, it might be in the form of audio, or it might be in the form of some kind of chart. So when you talk about big data is not so much easy. There are lots and lots of challenges over big data because of its lots of. First thing is you do not have any structure. It might be structured, it might be unstructured, or it might be semi-structured. Next one thing is there might be a very high velocity, high injection rate of data. Next one thing is domain-specific languages. It might be very difficult for process and interpret domain-specific languages. If the data is into English form only, so might it be very easier for you to analyze the data. So what if the data is into Nepalese language or some Korean language that you might not know? How do you analyze? If it is a fraud detection, fraud kind of data, so somebody is trying to inject or eavesdrop some kind of information from some security company. What if the data is not into readable form? What if data is encrypted? How do you decrypt it? How do you make it readable? So these are the kind of challenges that you may face. Next one thing is your semantics. Semantics are not same, so obviously you need lots of analysis, and cleansing and analysis process has to be cleansing and analysis process has to be streamlined into some structured manner. And the next one thing is, when you do have lots of data, next one challenge comes about the security. How do you maintain, how do you guarantee that the security can be implemented or security can be efficiently handled into your big data? So there is a challenge because big data will distribute your data into multiple clusters, multiple nodes. So you can't guarantee to cloud that your data is safe. How do you address this challenge? Security is a major concern. Might there be some kind of important, might there be some kind of very valuable kind of information that has not to be stored, that has not to be shared to the public or some other persons. So how do you take control over those kind of attributes? So these type of challenges also might appear into your big data when you are addressing to solve problem via big data. So this is all what I have summarized over big data. So for addressing problems over big data, we have technology, something Java. So Java is one platform where we can address our big data problems. Next one is the Python. And the technology designed for handling all those big data problems is a Hadoop. Next one, there is a real-time processing engine known as Spark and Storm. So if you talk about Twitter currently implements Storm at its backend as a framework. So Storm has been implemented into Twitter. So this is how the Storm handles its large data. At the back end, Storm for stream processing is being implemented. This is where I would like to summarize my talk. So now any questions, queries are welcome. Questions? के बुझियो? बुझिए ना? नेपालको कन्टेक्स्टमा फ्युचर के छ भन्दाखेरि अब यसको धेरै नै फ्युचर छ। किन धेरै नै फ्युचर छ भन्दाखेरि डेटाहरू हामीसँग धेरै छ। एउटा सिंगल ब्याङ्कको मात्रै केस लिने हो भने पनि ब्याङ्कसँग थाउजन्ड्स अफ गिगाबाइट्स अफ डेटा छ अहिले पनि स्टिल। ब्याङ्कको लगहरू, ब्याङ्कको जो ट्रान्जेक्सनको लगहरू हुन्छ त्यो थाउजन्ड्स अफ गिगाबाइट्समा चाहिँ त्यो लगहरू छ ब्याङ्कसँग। त्यो ब्याङ्कको लगहरू मात्रै पनि एनालाइज गरेर चाहिँ हामीले इफिसिएन्टली ह्यान्डल गर्ने हो, त्यसबाट केही प्रोडक्टिभ चिजहरू निकाल्ने हो भने त्यसमा लट अफ भ्याल्यु छ। फर इक्जाम्पल मैले एउटा सानो इक्जाम्पल दिएको थिएँ फ्रड डिटेक्सन सिस्टमको। ब्याङ्कमा चाहिँ कुन चाहिँ एटिएमबाट चाहिँ कतिवटा फ्रडको इन्ट्रीहरू भइरहेछ, कतिवटा गलत पासवर्डहरू इन्टर भयो, त्यति इन्फर्मेसन मात्रै पनि हामीले ब्याङ्कलाई दिन सक्यौँ, एउटा प्रोभाइडर चाहिँ युजफुल एनालाइसिस दिन सक्यौँ भने द्याट वुड बी मच 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 भ्यालुएबल फर एन अर्गनाइजेसन। Any question more? So IoT र क्लाइन्ट सर्भर मोडल भन्दा क्लाइन्ट सर्भर मोडल भन्नाले क्लाइन्ट एउटा डिभाइस। फर इक्जाम्पल IoT भनेपछि कम्बिनेसन अफ योर डिभाइस एन्ड इन्टरनेट हो। सो युवर डिभाइस इज अ क्लाइन्ट एन्ड इन्टरनेट इज योर सर्भर, हैन? सो त्यो भन्दाखेरि क्लाइन्ट सर्भरलाई मैले IoT सँग रिलेट गर्न सक्छु। क्लाइन्ट सर्भर इज नथिङ बट क्लाइन्ट भन्दाखेरि हामीले हरेक डिभाइसहरू जसले डेटा जेनेरेट गरिरहेको छ त्यो सबै क्लाइन्ट हो हाम्रो लागि, हैन? र त्यो जेनेरेट गरेको डेटालाई हामीले कुनै ठाउँमा स्टोर गरेर राख्दैछौँ फ्युचर युजको लागि या प्रोसेस गर्दैछौँ भने त्यो हाम्रो सर्भर हो। सो दिज आर द रिलेटेड टर्म्स। एनिथिङ मोर? Question. 10 more questions. So that is what client server model. So IoT मा के हुन्छ भन्दाखेरि lots of there are hundreds of clients. मल्टिपल डिभाइसहरु छ। हामीसँग एउटा मोबाइल छ, 100 वटा युजरसँग मोबाइल छ, 100 वटा युजरले अलग-अलगले डेटा जेनेरेट गरिरहेछ, है? त्यो डेटा जेनेरेट गरिसकेपछि त्यो एउटा सर्भरमा गएर स्टोर हुन्छ। अब त्यो स्टोर भएको सर्भरमा स्टोर भएको डेटा चाहिँ अर्को क्लाइन्टको लागि चाहिँ युजेबल हुन्छ। अर्कोले हामीले इन्टरेक्सन गर्दाखेरि क्लाइन्ट टु सर्भर इन्टरेक्सन गर्छौँ अन पेज। सर्भरले क्लाइन्टसँग कहिले पनि इन्टरेक्ट गर्दैन। सो द रिभर्स इज ट्रू। सो वी आस्क फर डेटा टु द क्लाइन्ट, वी सेन्ड डेटा टु द सर्भर एन्ड वी आस्क फर डेटा फ्रम द सर्भर। बिग डेटा को कुरा गर्दाखेरि बिग डेटा को एउटा मेन स्ट्रिमिङ टेक्नोलोजी भनेको अहिले दुईटा चीज छ, एउटा पाइथन अर्को जावा। सो these two are the foundational and fundamental programming languages which are run over big data. ये टेक्नोलोजी हामी युज गर्छौं। त्यही भएर if you are good at java so you may scale up in a very fast manner into big data, है? सम्म पुर्याइदे त्यो 1 लाख युजरमा पुर्याए बाबत म तँलाई चाहिँ $500 दिन्छु भनेर भन्छु। So that is how your data is important. त्यस्तो डेटाहरु नेपालमा पनि धेरै हुन सक्छ, धेरै छ। Just explore that and you might also find the big solutions. अरु साथी त्यति बेलासम्म हाम्रो सर्ट ब्रेक हुन्छ 5-10 मिनेटको। ओके, एउटा भेरी इन्ट्रेस्टिङ, यो भन्दा राम्रो इन्ट्रेस्टिङ बुझ्ने वाला सेसन छ। सो आई होप यु विल इन्जॉय लेटर। थ्यांक यू।